The Universal Model, Volume 1, The Earth System, Chapter 1, Introduction to the Universal Model.
Welcome. My name is Dean Sessions, and I'm so excited to be here with you today. We're here to learn about nature and why we're such an important part of it. What a great opportunity it is to be with all of you. I just want to give you a little bit of history about myself, and we're going to talk a little bit about today the overview of the Universal Model. I actually started teaching homeschool classes more than a decade ago. The Universal Model's been going for over 30 years. Since 1990, we've been researching all of the natural sciences. Our first textbook that we're going to be going over this year is called the Universal Model, or UM for short. It has a subtitle called A New Millennial Science. This volume 1 is the Earth System. And what this basically covers is everything about the Earth, meaning how it was created, why it's the way it is today, why are all the planets spheres and their moons. We're going to learn all about rocks. If you ever want to know something about rocks, that's what this class will teach you, is all about rocks, how to make rocks. We do things that geologists have never even dreamed of doing. And that's the exciting thing, is you all have an opportunity to learn things that no one else in the world even knows. Not even all the teachers in other classes at universities or high schools or elementary schools. You have a chance to learn things here that no other children in the world or adults are aware of. And that's the neat thing about the Universal Model. It's not just a theoretical concept. Science is supposed to be about things that you can feel, touch, and see. This is a quartz rock. It's a really nice size one. And as a crystal, we can hold this and we can tell what the density of it is. Density is something that is grams per centimeter cubed. A gram is the weight, and then divided by the volume, and this gives us the density of something. And we'll find out how density of things is real important. I also want to mention our second volume. Once in a while, I'll pop over to this volume, which is the living system. The living system is pretty exciting because in it, we're going to learn about everything that's alive. Okay? Well, the first chapter in here is called the age model. And in the age model, we actually talk about the age of not just the earth, but of human beings, how long we've been here on the earth. A lot of the things that we learn in the world today about millions of years and the earth being billions of years old is not correct. And we're going to explain why that is and how we do know the correct age of everything. And when I say how we know, once again, we're using science. We use things like dendrochronology. When I say words that you've never heard before, if you have a notebook and want to take notes while we're going through the class, and if you want to really be able to remember the things we're talking about, I would suggest, if you don't have one this time, to bring one. Because when I say something like dendrochronology, you want to write that down. That's tree ring dating, okay? Dendrochronology. So D-E-N-D-R-O, then chronology. Now, we're going to hear a lot of ologies in the class, O-L-O-G-Y. Who can tell me what they think ology means? Yes?
The study of something.
Very good. Did you guys all hear that? The study of. Okay? So when we say archaeology, that's the study of artifacts. Okay? Things that human beings have made. Geology is the study of geo, which is the earth. And so biology is the study of bio, right? What's bio? Living things. So ology is an important part of science. Matter of fact, I'm going to tell you a little quick story. When my daughter was about a lot of your ages. She was about 12, maybe 13. She was in junior high. And she came home one day, and she had gone to her class. She had a science class at school, and she said, "Dad, I'm really got a problem." I said, "What's that?" And she goes, "Well, in my science class today, we started talking about scientists. And I got all excited because I knew you were a scientist. And so I mentioned in my class, my dad is a scientist. But then she said, and she was very emotional when she went to tell me this, she said, but then I felt really dumb, Dad. I said, why is that? She goes, well, actually, because I didn't know what type of scientist you were. I couldn't say you're an archaeologist because you don't study just artifacts, or a biologist, or a cosmologist. That's the study of the sky. Okay, I couldn't tell them what you were because you study everything. Oh boy, and I realized as soon as she said that the UM is the study of all things, that we didn't have a name for it. I didn't know what I was to be called. Up to this time, I just told people I did scientific research. I didn't explain to them what kind of scientific research, because most scientists, if you're a geologist, you study just maybe this particular type of formation. You don't even study all of the rocks. You just study this one little thing, maybe the Grand Canyon, for example, and a certain time period in the layering there. So I told her, I said, well, let's figure this out, okay? And so we sat down, and we got a piece of paper out, and we started writing some words, and I said, we need to understand what the universal model really is, okay? And what everybody in this class is becoming. And we figured out the word ology, right? It was the study of. So we knew it was going to end in ology, but then we had to find a word for all things. And guess what word we found? Omni. Omni means all things, okay? So omnology is the study of all things, which is nature. And you all in this class are becoming omnologists. So I just want you each to know how exciting it is for me to be a part of all of you omnologists. We're omnologists and we study omnology. So all of us get this opportunity. When I told her this, she was very excited, my daughter Aubrey, and she got to go back to her class and help explain a little better what the universal model is. This is one thing I brought today. This is a dinosaur bone. This is a cross section. And what that means is this was a long bone like this, and this was cut like this and polished. When you go to look at this, I want you to recognize, obviously, the first thing you see is the white in the middle. That was an area, if I cut my bone right here, okay, what would we see in the very middle? Bone marrow, right, okay. What is the marrow, what goes on in the middle of the bone? The blood flow goes up and down inside the marrow of the bone. And actually, blood is made inside there, okay, in your bone marrow. So this is an area where there's liquid, and then liquids also contain gases. And we're going to find out that a lot of crystals, I'm going to go ahead and pass this around. If you look closely also, you can kind of see some of the inside of the way the bone was. This very middle part is almost all quartz, okay? In here, pure quartz. And you look on the back here, you can kind of see the bones that have been, this is petrified bone, okay? So this has been turned into a rock. It's also made out of the same substance this is. This is quartz. And you're going to learn, if you are writing down notes, quartz, and then put a little dash next to it, is SiO2. And S, and then a little I, capital S, little I, is silicon. And oxygen is O. So SiO and then a little 2. SiO2 is called silicon dioxide. Silicon dioxide, and that's quartz, or sometimes it's called silica. But that's the primary constituent of this. And we're going to learn this year, as we are talking about these things, why that has color, okay? Where does the color come from in rocks? This one's also made out of quartz. These are things that we're going to learn about. So this is another kind of rock that we're going to find out how it's made. And the fascinating thing to me about the is that we're also going to learn about FQs. and FAs. Who knows what an FQ is? A fundamental question, great. And what's an FA? Fundamental answer, okay. So I came up with a lot of FQs because some of them I was able to just observe. We're going to find this is called chalcedony. It's kind of a hard one to spell, but it has swirly things in it. It's also made out of quartz, but chalcedony is a beautiful rock. A lot of rocks are agates, and they're made out of chalcedony, and they have these little swirls and bends in them and so forth. I'm going to give you a word right now that is what we call one of our golden words. They're actually golden threads that go all through nature and all through the universal model. And these golden words help us understand multiple disciplines of science. A discipline is like biology and geology and physics and chemistry. Each one of these is a discipline of science. So we have an opportunity to learn all of these and see how they're interconnected. The key word to the colors of rocks is microbes. Yes, a small organism. So a microorganism, for short, we call it a microbe, okay? So basically you need a microscope to be able to learn about these small little, people want to call them bugs, but they're really just organisms that are really, really small. And it turns out that most microbes, almost all of them actually, are beneficial. They're very important to our body, to everything around us that's living, and they're important to even rocks. This is how we get colors in rocks, is from microorganisms. I do also want to mention, I don't have it up here, we talked about volume 1 is about the earth, and volume 2 is about living things. There is also volume 3. And volume 3 has not been published yet because it's not all written yet. And you guys in here don't realize it, but you're helping me write volume 3. And the way you're doing that is by asking questions. And the hard questions are easy when you know the answer. And this is how science, how we learn in science, how we come to understand things in science, is that we are able to ask the right questions. But I was going to talk about volume 3 for a second. I wish I had up here to show you, but I haven't actually designed what it's going to look like yet. But volume 3 is also a system. Notice each book is a system. And it's called the universe system. So volume 3 is new physics, chemistry, and astronomy. It's from the atom to the universe. So it's the really small things to the really large things. And there's a lot of information in volume 3. It basically covers all the physical things in our universe. We actually have, for the first time, a model of what energy actually is, and a model of what matter actually is. And you have to understand energy and matter to be able to understand either one of them. You have to know what they both are and have correct models of them. That's something else I wanted to mention that's in volume 1. We discuss in here that the chapters are set up so that they're either pseudo-theories or they're models. Okay? There's a couple of you I know that actually have read some of the book, maybe even all of it. Who can tell me what a pseudo-theory is? Okay, a theory that's not true, that's right. We actually define it as a false theory taught as fact. Pseudo is a false, okay? A word for something that's not correct. So a pseudo-theory is a false theory taught as fact. So some of the chapters in here, for example, chapter 6 is called the rock cycle pseudo-theory. Chapter 5 is called the magma pseudo-theory. So magma pseudo-theory means that it's a false theory taught about magma. When we were all the older moms and dads, if you guys can remember, when you were in school, we all learned that the earth was a sphere because it was a melted ball of magma, right? Well, it just so happens I'm going to pass around another rock. We're going to talk about this quite a bit because we're going to talk about rocks like this one is a black or a dark gray rock called basalt. Okay? And you will have a chance, B-A-S-A-L-T, basalt. Just realized, yeah, B-A and then salt. We're also going to talk a lot about salt. I was going to ask you, but now I can't because I already used the word, what kind of rock you think this is? This is actually a piece of salt rock. And the pure salt is the white stuff, and the stuff that's a little reddish there, that is sand that's been mixed in with it. This piece is actually from Utah. Down by Salina, there's a salt mine. And you guys know what that salt mine's called? The Redmond salt mine, that's right. And we're going to talk about that. We've actually been there and had a chance to go through there. But what I was talking about was basalt, right? Basalt happens to be, in your textbooks, is defined as the most abundant volcanic rock in the world. Okay? You're going to find out right now how to use the pseudo word, okay? When they tell you that something is the most abundant, that means what? That it's more of that than anything else. And so when you go to like places like Russia, we have maps in the book that show areas of basalt. And a lot of Russia, which is one of the biggest countries in the world, right? It has basalt flows all over it. They know this basalt had been moving at one time, and they all think it's a volcanic material, right? That it was melted. That's what they all tell you. Well, just to give you an idea how fun the UM was, I've had researchers working with me over the last several decades, and one researcher was working with me, and I remember telling him, I says, you know, I'm questioning this idea that basalt comes from a volcano, from a lava flow. And he goes, why would you question that? It's kind of like, everybody just knows that, right? Well, a real scientist, you learn to question stuff that you can't see with your eyes, okay? Or even if you're using a microscope and you still can't see, or you can't hear it. You have 5 physical senses, right? And those 5 physical senses allow us to gain knowledge. And then we use the 6th sense, which is reason or logic. And we use those 6 things to learn things. The problem is, though, a magician doesn't have a job if he can't fool your eyes, right? I could, out of my phone in my pocket right now, I could play a sound of a bird, and I could be back here in the corner and you not see me, and you wouldn't know if it was a real bird or if it was my phone, because our ears can't tell the difference. We're able to technologically make sounds that sound just like the real natural thing, like a bird making it sound. So we have a challenge here, okay? And this is what scientists have had a challenge with basalt, is they haven't seen something with their eyes. Yeah, but I want to finish with this basalt rock, because I'm going to pass this around right now, because I'm going to prove to you how you can know that this rock did not come from a lava flow. Okay? All I have to do is turn it around, and on the back side, and be real careful when you pass this around, because this little piece of rock here on the end is a what? It's a drip, and it can break off. I've had to glue it back on there, you can tell, because this is what the rock looks like when it's melted. Okay? I took a acetylene torch or a propane torch. So this is a hot flame that you would melt when you're doing welding and stuff, cutting through metal, okay, steel. So it gets to you have to have about 2,400 degrees to melt this rock. But when you melt it, that's what it looks like. Notice how it's shiny, right? It looks like another rock called obsidian. We're going to learn how obsidian's made also, which is not the way scientists think it is made. But this rock, if it was actually melted, would look like this, obsidian, okay? But it does not look like it was melted, and that's because it never was melted. Inside that rock And that's very important, by the way, because this goes to the foundational concepts of geology. When you take a geology class, your professor does not come up here with a torch and actually melt the rock. And that's a real problem, because that's what they say all rocks came from, was a melt. But they don't actually melt them in class and show them. Is that because it would go completely against all their theories? So we will jump around a little bit like this throughout the book because the UM is really interconnected. All the chapters, they're independent when you go to read them, but they're also connected to all the other chapters. This particular one is called, this diagram is called The Big Picture of Modern Science on page 52. Okay? And as you can see, there's two individuals in here. One is in the background of the theory of evolution. Who knows who this is? Correct. This is Darwin. And over here we have the theory of relativity. Who thinks they know who that is? Einstein. Correct. So as you can see, these three things came from Darwin's pseudo-theory. What is a pseudo-theory? A false theory taught as fact. Very good. You guys are picking these things up. And then we have the theory of relativity, which covers these three things. Now, what it simply says is we, meaning human beings, came from an ape-like creature. This is the big picture. If you go take a class right now in all the sciences, okay, so you could spend a whole year, take all your, if you're in college, for example, and you take every science class that there was at the university. They don't show this diagram, okay, because they kind of try to keep it hidden. And you'll find out in just a second why. But this is what they're teaching. And we actually have quotes here in the book. On the next page, you can read a bunch of blue words. The blue words in this book, we call them blue quotes, because they're actually the scientists themselves speaking, okay? This is from their journal articles. It's from the books they've written. It's their actual words. And you actually, after every blue quote, you have a little, some little letters after them, and it tells you the reference, even down to the page number, so you can go online and look those up if you want to read more about it. But it's there to verify that the quote is real. So this is what scientists say. They say that mankind came from an ape-like creature, which came from a bacteria, which comes from chemicals, which comes from a bang, the Big Bang, which came from nothing. How does something come from nothing? Not possible. Did you guys hear that? That's a very good answer. You can't get something from nothing. It's a very common sense thing. And unfortunately, a lot of scientists don't like common sense. There you have quotes in the book of them stating that we don't want to mess with common sense. See, we want to be extraordinary. And that's the problem with a lot of scientists, is they try to put themselves above the general public. And this is the real problem, because science, is it just for scientists? Is learning about nature only about the smart scientists that already know everything? Is that who it's for? Or is it for the general public? For all of us to learn about? Let's ask an important question. When was the last time you heard of a new natural law discovered in science? Was it in your lifetime? Your mother's lifetime? Your dad's? Your grandparents'? It's literally been generations and generations. More than 100 years since modern science has discovered a new natural law. For example, the law of gravity, if I drop something like this and it falls, if I know the distance, like 3 meters here, I can tell you exactly to a millisecond when it's going to hit the ground. Why? Because everything falls at 9.8 meters per second squared. Okay, this is the law of gravity. It falls the same rate all the time at the same place. Now, the reason it does that is not understood in science, but the fact that it does what it does and it's reproducible, that gives us a natural law. And a natural law is a statement of truth, because it's the same yesterday, today, and tomorrow. Do we have more scientists today or less? Way more scientists today. What about money going towards science? Do we have more or less today? Than 100 years ago, we have a lot more. And what about technology? Do we have less or more today? Way more. So with all the extra technology we have and all the money we have and all the millions of scientists we have, why don't we have more new natural laws discovered? Okay, a natural law is going to be something like we talked about the law of gravity. A lot of times there's mathematics involved with it, like F equals ma. Okay, that's a physics law. Force equals mass times acceleration. E equals mc squared is a formula probably everybody's heard in here. If I had it written on my shirt, you know, I would be an Einstein fan. Okay, E equals mc squared is something we got from the theory of relativity, which is a pseudo theory, by the way. And the problem with that is energy. If you want to say it's mass, m is the mass and c is the speed of light, and you square that, the units that are in there, units are something we're going to talk about a little bit later on, but it's the measurement. Mass times meters and time squared, so meters squared per second squared. That doesn't define anything physical. That's why that formula is incorrect. F equals ma, if you take a physics class, you can actually define the force because you can shoot. Like when I was in a physics class, I remember we had little balls, and we would predict how far away our ball with this force would land when we shot it from a spring, and it would land over here. We could predict how far it would go. And they use this in artillery when they're shooting tanks, for example. They have to know, because they know the weight of their projectile, where it's going to go, and it's going to hit on the other side, the enemy's side. And it's very important that they know their trajectory. And to calculate all that, they use laws, okay, natural laws. So there can be, in biology, there's natural laws that can be done. A lot of times modern scientists have gotten away from defining them, okay? They have to be reproducible and defined, and usually they're quite broad, and they will apply to a lot of things. We have some laws when we get to the magma chapter. We'll talk about how rocks are not made. And then when we get to the hydroplanet model chapter, then we have some natural laws that show how rocks are made. Okay, and we can use those and discover how those are made. In volume 2, there's a chapter called the evolution pseudo-theory chapter. Pseudo-theory is what? False theory taught as fact, okay? And at the very end of that chapter, we actually find out that there is a lot of unfortunate things that are taught in evolution, okay, and about evolution. And here's the reason why the modern scientists today cannot look for natural laws. We talked about natural law being a statement of truth, right? The scientists, leaders, took their own survey, and when they took their survey, and this was back in 1998, we have 2 different journal articles reporting on the survey. When they took their survey, 93% of the leaders acknowledged themselves that they were agnostic or atheist. What does that mean? It means they don't believe in God. Today, it's even higher, much higher than 93%. So we're looking at more than 9 out of 10, almost all. In some universities you go to, like Harvard, the biologist department head admitted everybody in his department was an atheist. And that's very sad, because not only can you not prove that there's no God, okay, scientists can't prove that, because first off, if everything came from an explosion, I'll make it really simple. If everything came from an explosion, everything would randomly be all over the universe. If I blew up this table, okay, is it all going to fall down and look like a poster like this one over here? No, if I blew everything up, it's just going to be randomly here on the ground, right? But that's not how nature is. All of you are organized. You have cells in your body, And the amazing thing is science can't make one of those. Billions and billions of cells, and they don't know how to make one of them. The same thing with every rock. Every single rock like this that's natural is organized. And we're going to learn how rocks actually have water inside them. Okay? When I say that, I'm referring to this rock here. Some of you guys have seen this already. I'm going to pass this one around. This one, you hold it like this and move it, and you can actually see a bubble inside it. Why would it have a bubble inside there? That's because there's liquid and a gas inside there. So that's called an enhydro, E-N-H-Y-D-R-O, enhydro. Very important word. We're going to learn about how rocks are made. And water is one of those little golden threads we talked about, right? That's going through all the sciences. But we talked about microbes was a golden thread. Well, water is another one. Very, very important. The scientists are, I wanted to make sure we had this understood, that modern science, because they are not believing in any type of creator, everything has to be unorganized. And that's a big problem because everything is organized in nature and everything around us. This is one of the main evidences that there is a creator, okay, is because not only can we not create all these things, like you look at your body, for example. You go ask your mom, hey mom, did you make my body? Or ask your dad, did he make your body? Neither one of them made your body. And they didn't make, their parents didn't make their body. There's no human being that can make another human being. Okay? This is because there's a higher intelligence involved. And so this is where we go in and explain in volume 2 that there had to be higher intelligence to organize unorganized matter into organized matter. And that's what a creator does. Okay? So if we look here on volume 1, in chapter 1, on page 6, you'll notice each of these chapters have subchapters. And the subchapters are in red. You can see the red there. And 1.1 is the first subchapter, chapter 1, answers to questions. So if you read through here, there's the answer principle, and that is answers come from questions. So don't ever, it's really important that none of us ever feel that our question is a dumb question, because there isn't a dumb question. Okay? All questions are good. There's nothing that actually stimulates the mind more than a question. And when it's an FQ question, that's a fundamental question, now you're getting down to things that, whoa, I've never thought of that before. And that's why we want to use questions. Now, answers come from questions. You notice the green words there on the top of page 7. The answers come from questions. That's really important for us to recognize the importance of questions. So the next subchapter, that is where you see the black words here at the top under a subchapter. It's called a subchapter. We have the key to a puzzle. And when you guys get a chance, you might want to try to do this down here. Let's see if I can do it up here real quick. I haven't done this for a long time. But you can do this to a friend if they've never seen it before. You can put 3 dots like that. Okay, so now there's 9 dots, right? And you give somebody 4 lines, right? We give them 4 lines and say, okay, 1, 2, 3, 4. Anywhere you want, you have to draw 4 lines, and you can't take your pencil off the paper, right? And try to cover all the dots. So the problem is if I go 1, 2, 3, 4, I missed a dot, right? Doesn't work. So there's only one way that you can make this work, and you can't just keep doing the same old thing. I can go, well, what if I go 1, 2, 3, 4? No, that doesn't work. What about 1, 2, 3, 4? That doesn't work. If you stay within the confines of all the dots, you'll never figure it out. Here's our dots. Okay, there's 9 of them. We come past it once, and then instead of going through the middle one, we have to go through these 2 over here. Come all the way up, and once again, you have to go past it. Then you come down all the way to the beginning here, this corner, and then you can come up. So as you can see, you have to go past the dots to figure this puzzle out. And this is the way that a lot of things happen in nature, is we have to go beyond what our eyes just see or what we've been told all of our life. Okay? For example, in 1.2, we have the question principle. And the very first green words that we see there on page 9 is to question everything with an open mind. I want you to think about that for a second, because that really is going to tax you when you start questioning everything. But why is it okay to question everything? The reason it's okay is if you have found something that's true, when you question it, you're going to come right back to what's really real. Okay? For example, let's ask ourselves, what is truth? Let's say, for example, 2 times 3. If you were taught that it was 5 in school, how well is 5 divided by 3 going to equal 2? You see how it doesn't work, right? If 2 times 3 really equals 6, then 6 divided by 3 should equal 2. Right? We could reason one with another about that. So this is how logic works. This is why it's okay to question things, because if we have found the truth, if 2 times 3 really does equal 6, every time I have 2 columns of 3 things, I can go and count them. I'm going to have 6 things afterwards, every single time. So it's okay to find truth and to question it, because you're going to come back to the same answer every time and confirm what you thought. So this is why down here in the bottom on 9, you notice the little gold words. It says correct principles are like icebergs. We all know what an iceberg is, right? When it's floating in the water, we only see a little bit on top of the water. What's underneath the water? A lot more ice, right? It says their meanings lie far below the surface. So principles, like you'll see here in gold words or in these green words, okay? The principles are truths. They're things that don't change. And that's why they're important to have. So on page 10, there's a textbook question. Okay? Who wants to tell us, has anyone read this part and wants to tell us this little diagram here? This is all about salt. I remember, this is one of my other researchers I had. I asked him, I said, remember I talked about the basalt situation? I forgot to tell you, I guess. We passed around that little piece of basalt somewhere. And I remember asking him, I said, I don't really think basalt comes out of lava flows. And he goes, well, what do you mean? Everybody just knows that, right? So what I did is I asked him, I said, when the UM first started, there was no internet, by the way. We had to just go use to libraries. We had to find books. We had to talk to people that were an expert in that field and knew a lot about it, right? And then finally the internet came out, and you can't understand. You've all grown up in here. All the kids have just having the internet, okay? But it always wasn't there. So in the olden days, when you went to a library, you'd go into a big card catalog and had all these little cards, and they had a little piece of paper, and you pull out, and it would say the book's name and where you go find it, and that's how you found things out, is through books. But now you go to something called Google, right? You guys all grown up with that, and you just type in basalt, and I had him research someone that's seen with their eyes a lava flow cool and turn into basalt, and taking pictures of it. I want to see basalt that actually came from a live lava flow. He goes, okay, I'll find it. And he goes and looks all that day and the next day and the next day, and guess what he never found? A lava flow cooling into basalt. And guess why he couldn't find that? Because basalt is the same as this rock. It's made in water. We're actually going to show you how every single natural rock that we pick up outside, you're going to be able to do an experiment in your own home when you go home that will prove that there's water in every single natural rock. And that's because rocks grow out of water. We're going to talk more about that, how rocks form. So when I asked him about the basalt thing, he came back and it was very surprising to him that he couldn't find a picture of anybody that had ever taken of lava cooling and being a basalt. And that's because the basalt actually has to be under a lot of water. Okay, there's something called basalt pillow lava, and this is down the bottom of the ocean where basalt's actually made, coming out of a fissure or a fault line. When you have melted rock coming out, and if it forms into basalt, it has to be under pressure, underwater. So that's a real problem. That's why up here on top of the land, when there's lava flows, like in Hawaii, and you see coming out of a volcano, that'll never be a basalt. Okay. So we also had another question I asked him one time, and that is, if you open a chemistry textbook, you look in the bottom of page 10 here, you can see they say Na plus Cl, that's sodium plus chlorine, equals NaCl, or salt. This is a very common formula that you'll find in textbooks, that sodium plus chlorine added together makes salt. This is what you learn when you learn chemistry. They take elements like this. Sodium is an element. It's a metal. It looks like a piece of aluminum. And then chlorine is a gas. It's a yellow greenish gas. And if you put those two together, it's supposed to make salt. The problem is that when I told my researcher that I didn't think sodium and chlorine put together make salt, and it's like, well, what do you mean? It's in all the textbooks. And I said, well, go find someone that's actually observed it, right? Who's actually seen salt being made from this? And so he had a chemistry professor in his neighborhood where he lived. My researcher was Rod Meldrum, and he worked up in Provo. And he went to this professor and said, yeah, can you show me, where you actually have a formula that's making salt, sodium chloride with Na and Cl, this is your table salt that you eat with your food and stuff. And he says, oh, yeah, I can do that. I'll show you. It's in one of my, he had a program on his computer that he'd go in and find all this stuff. And so he ends up calling me back and telling me, Dean, I'm really sorry because I know you wanted to find somebody that had made salt with just sodium and chlorine, but I couldn't find anybody. I talked with him. I talked with other professors. I looked in the book. I looked on the internet. And it turns out that that's not how salt is made. And this is the problem with chemistry, is they say certain things happen this way in the textbook, but they never demonstrate it to you. They don't actually show you. And that's the real problem that we have in science, is we're not shown these things. Because the reason I did not think this takes place, Na plus Cl being NaCl, is guess where you go in nature and find sodium by itself. So this is a silvery metal. If you look in that book there, the picture I was showing you, it just looks like a little piece of aluminum. This little piece of sodium, you can't go anywhere in nature and find that. Matter of fact, I had a chemistry teacher that told me when he was a kid that they actually got a chunk of sodium, and they had a cabin up in the woods, and they had a little lake by it next door, and they thought, for fun, we're going to throw this out in the water, because they knew when you put sodium in water, it does something. Guess what it does? It explodes. And the explosion was so big, he said, it blew the windows out of their cabin. So this, you can find out we'll see. If I get a chance, I have to go through my boxes. I recently, when I moved here from Arizona to Utah, a lot of my stuff is still in boxes. But if I can find my some of my chemicals, I have some sodium. If I can get a little piece of it, because I want to show you, you get a little teeny piece of it, small enough, and you put it on the top of a glass of water, and it goes bzzz, and it literally is burning up, and then right in front of you it buzzes around, and then it all goes away. So once again, when we don't have an element in nature like sodium, that's a real problem, trying to make salt from something that doesn't exist, right? And then chlorine, which is this gas we're talking about, guess where we find that in nature by itself? Nowhere. Okay, chlorine, if we let chlorine gas go in here in this room, it would kill all of us. Think about that. Okay, they put very dilute amounts, small amounts in your water systems to kill the bacteria in your water systems. And it's not that good of a thing because it actually kills good bacteria as well as some bacteria they might want to say is bad. But the problem of not having chlorine or sodium in nature is you can't just put the two together when they don't exist and make salt. So we're going to talk about how salt's actually made. That's one of the things we're going to talk about. On the next page, on page 11, there's a sub here of how to question. And you'll notice there's 4 words there that are real important. You want to think about these as we go throughout the book throughout this year. Because when you question something, you don't want to do it critically. You don't want to be skeptical or be partial. We want to do what's on number 4, which is objective. Okay? So notice down here the green word, it says which is the answers presented as the best answer. And that's how we can be objective, is when we hear multiple answers to a question, there's going to be one answer that's going to be the best, and that's how we're being objective when we try to find out new discoveries of things. Okay? So we also have something called the learning process. We'll talk about this more as we go through the year, but this is a real important part. You would definitely want to write this down in your notes and get this memorized, because the learning process is how we learn all things. In nature, there's 6 questions that cover all the questions. Okay? 4 of these questions are the physical side of life. Where, what, when, and who. Those 4 questions, where, when, what, and who, are all physically described. The other 2 questions are how and why. How and why are an explanation. So those are the 6 questions. What, where, when, and who, how, and why. So what, where, when, and who turn out to be what knowledge is. And the wisdom is how and why. So this explains both the intangible side of life and the physical side of life. You comprehend wisdom and you understand knowledge. This is probably the most fundamental, important thing you're going to learn today, and maybe even our whole year here, okay? Because this learning process will affect you in all your life and through all disciplines of study, okay? You will find, to know the difference between knowledge and wisdom, it's extremely important. And it's not understood in the world today. They don't even know what these are. Now, we also, we're going to end with this, is what is knowledge? Well, in the we explain truth, and we define it as in 1.5 here. So this is on page 16 and 15. Okay? We talk about definitions. It's really important. If we don't say what we mean, we don't mean what we say. Okay? So how important is truth? Well, I want you to make sure you read through this, because without truth, when I go to leave here and turn the key in my car, if I'm thinking I have a battery in my car, that's why I'm physically turning the key, right? Well, what if someone stole my battery? while we were in here in class. Is my car going to start? No, okay? So it's important for you not to waste time, okay, and to do true things. And truth is right down here in the bottom on page 16 on the right-hand corner. We define it as truth is knowledge of what is, was, and will be. Knowledge, that's what truth is, of things that are, things that were, and the things that are going to come. So it has to have something called the test of time. You have to pass 2 times 3 being 6 yesterday, today, and tomorrow. To find the true definition of any word, we must first know what truth is. And the problem is, go to your dictionary.com on your phone and type in truth. It's not going to have the correct definition. And the correct definition is not even in the Bible. It doesn't say truth is somewhere and give you the answer. So this is really critical to recognize that you are a group of people, very few in the world know what truth is. How do you know the true definition of any word if you don't know the definition of truth? I hope you guys are excited this year to learn and comprehend and understand things that you've never understood before. You will refer back to these introduction chapters as you go through the year and find you learn a lot of things over and over because you don't catch it all the first time. So if you didn't understand everything, that's okay because we're going to talk about it again. Thanks again so much for being here today and have a great day.
For more information, please visit universalmodel.com. Use the coupon code UMClass to receive 20% off your purchase in our store.